Do computers and shit make you batshit crazy? Press F1 to boot. I think I have a tool that'll fix it. Just as I thought. It's f***ed. Your hard disk needs formatting. Hard drive permanently formatted. 1-800-487-353 or 1-800-IT'S f***ed. Call now, operators are standing by. Greetings, the Astro 30 here yet again, looking at this. Well, I'm going to do some work on this power supply today. Now, in a previous video I mentioned about the inaccuracy of this VA meter here. Now, if you remember in the second video in the series of this build, you saw that I would have taken this meter actually out of its casing and pulled it apart. So I just took this meter apart because I was measuring a dead short across these wires. Okay, that was a considerable amount of effort than necessary, but I've got this out. I was confused as to how that was supposed to be wired and how it actually worked, and I forgot basic electronics 101 of how an amp meter works. But anyway, that was just a little bit of a brain fart. But I reckon in the process of me unsoldering that shunt and then resoldering it back in, I may have either damaged the board in some way, or like a component, or the resistance of that shunt has changed due to the amount of heat that was put through it. That is a possibility because I've seen videos on YouTube of people using this very VA meter in power supplies and whatnot, including switch mode ones and stuff. And when they get the current reading on there, it seems pretty well accurate to whatever the load is that is connected to it. So there should be probably plus minus 5% error that I've seen on videos in YouTube there. So why mine is like plus minus 30% could be having something to do with removing that shunt there that's behind the connector. Plus it's in at a funny angle, so that connector doesn't fit properly anyway. So the only way to prove that theory is I have another one of these on order, which I was hoping would come today, but hasn't. Other stuff has come today, which is for a later video, but this hasn't. I ordered another one about 2 odd weeks ago. Thought I might as well order another one. And it's probably a good idea that I did, because I'm going to just unplug the one that's already in here and plug the new one that I get in, and then compare the two and see if the second one's more accurate. And if it is, what I'll do is won't bother trying to pop out this plastic surround. I'll pop the circuit board out of the new one, pop the circuit board out of this one, and then swap them over. And what am I going to do with this? One, if it proves to be damaged and the other one's more accurate, well, the voltmeter still works, so I'll probably use it as, I don't know, just a voltmeter. Anyway, enough crapping on about that. I'm going to make some modifications today. I'm going to first change the mounting of these transistors. Now, this heatsink would be alright if there was a hole cut in the chassis and the transistors were directly contacting it. However, there is not. I've got me this more substantial heatsink. It's a HH8555. And it's 150 by 75 by 46 millimeters with bare aluminium on the mounting face and anodized black material on the fins, etc. So what I'm going to do is I'm going to mount this to the back panel with one screw either side of the heatsink. I'm going to cut a hole out in the back panel here with my whatever it's called, my mini angle grinder. Had a mental senior moment there. Then I'm going to drill 2 holes through the heatsink in between these fins, obviously, so I can get the screw in there. Yeah, mount the transistors directly to the heatsink. So there it is there. Now, as we can see, it's a pretty substantial bit of material there. That's at least 5 millimeters thick on the face, and the cooling fins taper off, and the gap between each fin is 5mm, so it's just big enough to get the head of the screw through to mount the transistors, and each end's got a larger gap, at least 10mm there, so you can put chassis mounting screws. So I've got to clean off all this heatsink goop and crap. Now I can't really take the supply apart to cut the hole, so they'll have to stay together. I will take the bottom panel off so any debris and stuff can just fall straight through. But yeah, that's my plan of attack. Also, these current limiting LEDs aren't very bright, and that's a very simple reason why. I've got heatsink compound over everything, look at it. Man, it's all over these pots. It just went everywhere. Now what am I looking for? These LEDs that come with the kit would be high brightness, high intensity red LEDs. That's why they're in a clear lens. These are high brightness. So what they've done is they've put in a resistor drop, or drop a resistor I should say, to bring the brightness level down. Oh, that fart stunk. And that's why having a schematic of it helps. See, they've got a 3K8 resistor here in series with the LED. Now, because I'm using standard red LEDs, I think they're only just, excuse me, I think they're only just 20 MCD brightness or whatever. I have to look it up, but anyway, they're the lowest intensity that you can get, the standard intensity. They're not bright enough because of that 3K8 resistor in there, so they glow dimly. I can make them glow twice as bright so they're at least a bit more visible just by changing that 3K8 resistor to something like 1K5, so I'm going to halve it. I can even go as low as 1K2 I suppose, or even 1K would do it. So that's the plan of attack today. I'm going to start by first marking out where I'm going to be drilling the holes in the heatsink there. I'll take off this old one and clean off the goop, and the easiest way to get my holes in my heatsink that mount it to it to line up is to hold it up against the panel, clamp it, just put a drill through it so it drills straight through to the case, and then put bolts through. But then I've got to cut out the hole, which is going to be the hardest part and the slowest. Okay, got it marked out. I've come in 9mm from the edge because that puts it 5mm in between the 10mm gap, and there's a 4mm distance between here and the edge, so that makes it 9mm. Gone to the center point of this, which is 37.5. I've come in from the right hand rear edge 70mm, so that lines up with the middle of a fin here, so I can actually, well, in between two fins, so I can get a screw in. And I've gone a distance of 20mm apart from the center line, so that's a distance of 40mm for both transistors. So we've got about 20mm of material here and 20mm of material here, and that should just be enough. However, I'm going to have to cut out a rather large hole in the panel, and I've tried to keep this in roughly where the two holes in here are, so I know where I'm cutting, so I don't have to like guess. And so I reckon I'm going to have to do like a fairly decent sized hole, at least 60mm either way. I'll cross that bridge when I come to it. Now all I've got to do is just center punch those here, here, and here, and here. Drill those to 3mm and drill those two to 4. Okay, so I've got that drilled. I've decided to keep those edge holes to 3mm because, well, where I measured it, those holes are very close to the fin, so I'd never fit a 4mm screw in there because the head's about 5mm, 6mm. I should have come in 8mm because where my thumb is actually only a distance of 4, not distance of 3, not 4. So I'm going to keep them all 3mm, that should be fine. Those center ones just line up with enough space to fit the screw head in there, so I had to massage one of them because it was slightly off, but oh well, doesn't matter, right? So next is to do the messy part and take that heatsink off. The fun begins. So just going to unscrew these transistors. So now, oh my, that's got quite a bit of suction behind it. Damn. Shit. Wow. This old heatsink will be reused for something else later. Right now I'm just going to use some toilet paper first to get the majority of this stuff off. Well, that was a waste of heatsink compound, but that was a cheap tube. I think I only paid about $5 for it. Now I need to get the old heatsink goop off of the old heatsink here. Bit more alcohol. There, that gets the majority of the crap off. I'm not really worried about super clean at the moment. See if I can get this off my fingers. Because actually they do say that with heatsink compound you should really avoid skin contact with it. And well, so back to what I was doing, which was playing with myself. No, I've done it already. I really need to tie these transistors up out of the way whilst I'm working, so I'm not going to, you know, drill through them, take these thermal isolators off, and what I might do is I might use a cable tie for that. There we go, I'll do. I don't have to cut it off, I'll leave it as is and I'll just cut the cable tie when I'm finished. Now for the heatsink, the piece de resistance. So I'm going to mount him probably close to where those old holes are. I can see where one is. Actual fact, surprisingly enough, both holes line up. Interesting. Okay, so I know I'm in roughly this area, so I'm not particularly worried about the holes because they're irrelevant to what I'm doing here. So what I'm going to do is I'm going to clamp, if I can, somehow clamp anyway, the heatsink in place, heat sinks in space. Okay, and then I can just do a visual, how you doing sort of, let's line it up sort of thing. So it looks reasonably square, which is about there. Make sure that's as tight as I can get it. As tight as I'm going to get it. Just do another final visual inspection, make sure it looks straight. It does to a point. Alright, 5mm there. 6mm there. Yeah, that's perfectly straight now. Of course, I've got to be able to get the drill bit to clear the heatsink, so I've stuck it with all about 4mm holding it in, so it can go through the width of this without, you know, stopping and not actually making its way through. But at least I now know with it like that, it's not going to hit the back of one of these transformers, so it's perfectly safe to drill it like this. Just put it through the hole. That's one. So I'll stick the screw through the hole I've just drilled, so it holds it, well, if I can, holds it in centre. I'm just sort of eyeballing it. Doesn't have to be like, you know, perfectly straight, but it'd be nice if it looked straight. And that's about it there. Okay, tighten him back up, and then I'll drill the second hole. Okay, that's done. So all I'd have to do now is just deburr the back of those. I can just use the edge of a file for that. But what I'll do is I'll wait until I take this bottom off, and yeah, then I can. What are you trying to say, Astro? Then I don't have to worry about things dropping into the bottom of the case and sitting there and rolling around like sharp bits of metal and shorting on things. Jesus, my farts stink. Okay, the bottom panel is off. These two end holes are deburred. All crap gotten out of the case. Now I've just got to mark out where I'm going to do my cutout. As I said, I'm probably going to make it... Well, the heatsink covers the majority of the top and bottom of the case by, you know, like 5 mils, so I can come up to just above those holes. So if I come to here and roughly there, look at that, should give me plenty of clearance to mount the transistor doing that. So I want to come, this hole doesn't have to be terribly accurate or straight. I will put a T-square on it and make sure it's at least semi-straight. Because remember where these holes are is with the holes I've drilled in the heatsink, so this is where the transistor area is. Except the first transistor is about there, the second one's about there. So I reckon a hole that size would probably suffice. So what I'm going to do is put that on a T-square, make sure it's at least, you know, square, and then cut it out with a Dremel and come back after I've done that. Progress, I've got one slit cut, took me about probably 10 minutes, so I reckon to do all 4 sides it's going to take me at least 40 minutes. So yeah, I'm going to keep going with this. This is actually proving to be a very handy tool. It would be nice if I had like a bigger angle grinder or a milling machine or something to cut that a little bit quicker, a plasma cutter or something, but well, I don't, and considering there's like transformers and stuff behind here, I don't really want to put a lot of heat into things. Well, there we go. We have a hole. Just going to clean that up a bit. Okay, it doesn't have to be perfect, as long as there's no really rough, sharp edges on it. We have ourselves a hole. Alright, now that's one way of making a square hole. There are several ways of doing it, but that throughout the entire project has been by far the easiest way to do it. So that little grinding tool by Duratech was the best tool purchase I've made so far. And in fact, the more I think about it, most of the tools I have, including my soldering iron and solder, are Duratech brand. Interesting that. So now I can mount my heatsink when I can find where that screw went. Right, that should hold it nice and firm. I think there's just enough space here and here for a transistor to mount. I'll just cut my cable tie that I put in earlier. So that was the top one. This I think was the bottom one. And yeah, I do believe there's enough space there. I might have to bend out these leads a little bit from the case, just to prevent them from touching the sides. Okay, so time to remount the transistors. This should work a lot better at dissipating heat than the old idea. So grab our isolator, our transistor. Now, next thing I'm going to do is make sure that both collectors are isolated from each other and the heatsink. Now we're perfectly isolated from each other, and just to make sure, I'm going to check every pin that comes into the board for each transistor to make sure that none of these leads are touching the chassis, which they are not, which means the transistor is perfectly isolated, collector base and emitter, from the case. So that means that this heat shrink is working and protecting it from shorting. So that means now I can actually power it up and we can do a preliminary test to see how well the heat's dissipated now. Okay, so I've got the power supply set at 9.9 volts. Ignore the amp meter. It's across a 10 ohm 10 watt resistor. So I expect the rough current draw to be around about 900 mA. So we'll just turn the load on and do a preliminary heat test. Those transistors are still getting red hot. I'm going to reduce the voltage to 5, because it should be sinking straight into the heatsink, which it is. I can feel the heat on the heatsink. Maybe I need better heat transfer. Okay, that's a bit of a concern. I would have thought that I would have thought that putting it directly to the heatsink with these greaseless micro washers would have done the job. And I can feel the heat going into the heatsink, but the transistors are getting hotter than the heatsink. What are these drivers doing? Not even warm. So that's concerning. That's the resistor I can smell cooking. I'm going to lower the voltage even further, about 3 volts, because that resistor's starting to smell. I might prop him up on something so it's not going to burn the desk. So yeah, I can feel the heat going into the heatsink. The heatsink's getting nice and warm now. But I'm a bit concerned at the junction temperatures of those transistors. They're red hot. So the way I had it was working, but I wasn't getting this much heat transfer into the older heatsink, so connecting it directly to the heatsink is a better idea. So it is getting hot, and well, that resistor's red hot too. Because the one thing I don't want to do is I don't want to burn out or destroy these transistors. But yeah, they're not really transferring the heat properly. So I might have to change them to micro washers with heatsink transfer compound to try and sink the heat a little bit better away from the device. Because even the casing's getting a bit warm too. Because yeah, it's not there's probably a hot spot right around where these bolts are. Instead of actually evenly dissipating the heat into the heatsink as it should be, it's getting hot, because technically speaking the heatsink should be the same temperature as the device. But this is colder. This is feels like about 30 degrees, 40 degrees Celsius, maybe 60, close to 60. This is about 120, because that's like twice the amount. So I'm going to do a current draw test. Shit. 610 milliamps. Yeah, 610 milliamps. So there's like, through both those two transistors, they should be sharing 300 mA each, roughly. But 300 mA at 3 volt, it would help if I was on dual. That's better. I still had 6.4 volt going through it. I had this switch set wrong. It's actually wasn't 3 volt, it was 6 volt across the lot. So when I had it set to 10 volt, I was actually putting 20 volt through it. So yeah, okay. So I'll drop it down now properly to 3 volt. That's close enough. Now we're getting a current draw of 300 mA. I can still feel that that's nice and warm, but these have cooled off a bit. I think what I'm going to have to do, without making this particular modification long and boring, is change those isolators to micro washers with some heatsink transfer compound. I can't connect them both directly to the heatsink, obviously, because they'll short together, and that's not what we want. But yeah, but mounting it to the heatsink was a good idea. Now, as for the current limiting, as we can see, the LEDs aren't quite bright enough. We need to change that 3K8 resistor to a 1K5, which could prove challenging considering everything's wired up. It is sinking the heat properly, so I might leave it alone. If I blow the transistors, I blow the transistors. It just means they're cheap Chinese knockoffs of Japanese transistors. What I should do is probably go check the datasheet for the 2SD1047 and see what the actual SOA curve of this device is. Its features is a high breakdown voltage of 140 volt, typical frequency 20 megahertz, fully characterized at 125 degrees Celsius, and its application, power supply. Maximum. What can I say? Maximum operation junction temperature, 150 degrees Celsius. I was almost right when I said its SOA would be about 160 in the last video. I was close. So the junction temperature, that is the collector and emitter junction temperature, maximum across this device should be 150 degrees. And without a thermometer, I cannot really tell you how hot that's getting. But we're only running 300 mA through this device, or both devices, so it should be sharing equally at 150 mA each. And even at 150 mA, it's getting quite hot. But then, really technically speaking, that resistor is almost providing like a dead short across the circuit anyway. So in the real world and real world applications, this sort of scenario is not going to happen. Not unless you like frying resistors, of course. So I'm going to move on. This has been running for a good 10 minutes and it's been steady at 300 mA. It's not overheating, there's no thermal runaway, so the heatsink is actually warm to the touch all the way along, so it's sinking the heat as it should. The transformers are mildly warm. The drivers for the Darlington output, the heatsinks are stone cold. So now I'm going to move on to the limiting lights. I think the easiest way would be to extract the resistor from the top side of the board, then take the board out after cleaning up the holes and solder the new one in. See, that was relatively painless. Now I just need to clean out the holes. This says 3K9, the circuit diagram says 3K8. Oh no, it says 3K9, I misread it, my bad. One hole. No, just put straight over the board. It's 2 holes, now I can do the next resistor. Right, I can screw that back down. I've done the other one already. So now there are two 1K5s. This one was giving me a bit of a problem trying to desolder the hole, like pull the solder out of the hole. In the end, I just took this, 0.8 of a millimeter hookup wire, link wire, and just shoved it down the hole whilst heating the connection, and that cleared the hole out just fine. Now, current limiting. That's a little bit better. It's a bit brighter. 1K probably would have been better, but it is a mild improvement. Now, continuing on with the heat transfer thing from the transistors, I did happen to find these old mica washers I pulled out of an amplifier when I changed them over to greaseless mica washers. And I kept them because, well, there's nothing really wrong with them. They are TO3P. So all I need to do is, take those ones out, smear some heatsink compound over these. I've got 2 of them, and then see if it transfers the heat any better. There's heatsink transfer compound everywhere now. That's some more runny consistency than the last lot. Okay, load on. So I'm going to wind the voltage up to 6. Oops, that's too far. 6. So we're drawing about an amp now. And from what I can feel, those transistors aren't getting as hot as they were before. I don't think it made a difference using the mica washers versus the greaseless TO3P isolators. It's basically the same thing, but I feel a little bit more, safer, confident having it that way rather than the way I had it. Alright, so I'm getting about 630 milliamp draw. So those transistors are mildly warm. The heat sinks are roughly the same temperature as the devices. So I'll wind the voltage up to say 8. So I'm now getting 790 MA. And again, they're starting to warm up a little bit hotter. They're hot to the touch almost. I've got to wait until the second VA meter comes in. It's relatively easy to get these out. There's only 2 clips on the side and it pop out. So I've got to wait for that meter to come in so I can hook it up and test to see if there is actually a difference in the amp readings. Right, I'm reading exactly 300 MA. Well, it was 290, that's close enough. 3.2 volts is the voltage, so I'll keep that in mind. Now we're at 300 MA and that says 180, so we're at least 120 MA out. So as I say, I've got to wait for the other module to come in so I can do that comparison test at that voltage, 3.2 volt, 300 MA, and see if the new one's any more accurate. If it is, I know I've done something to this meter because I've pulled it apart. That's my gut feeling on this, is that because I pulled that meter apart, it's put it out of whack or damaged the component. So anyway, we'll revisit this later when I get that module. Should be in the next couple of days, I hope. And then I can finally put this project to bed. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying see ya, have a great day. That poor 10 ohm resistor, little did it know in its life it was going to be used as a direct short shunt load test. Poor thing.